Good morning, everyone. Uh, Today will be discussing eudiometry. This is a very important topic and interesting topic as well. Now, eudiometry is based on the application of gay music law. It is based on the eudiometry, based on the applications of applications of gay sex law of combining volumes. Right now, this is the first question. I will explain you how to solve the questions on idiometry. These types of questions involve some tricks and fundamentals. Uh, in this video, I will be telling about that concepts and basics. Now, the very important first concept. Let me keep this question aside. I will discuss it later. Just a minute. The this is the one of the concept. The second comes. The second comes that we calculate the the contraction in the volume. The contraction is there in the volume. These types of the idiometries are based on the contraction of the volume and finding the the hydrocarbon which we are given in the questions, right? uh, Let me give you this the equation which you all have to learn. Suppose a hydrocarbon is burning in the presence of O2, O2 CXHY. This is the hydrocarbon, let it be. And if I burn the hydrocarbon with O2, then it gives me mm, something like CO2 and plus H2O. This we know, but the what is the balanced equation? We want balanced equation in idiometry. So the balanced equation is written as follows: CXHY. This is the hydrocarbon we are given with. Now plus X plus Y by 4 O2 gives you XCO2 plus Y by 2 H2O. This this is the equation you have to learn, right? Moreover, now the sometimes questions involve not only carbon and hydrogen, it also involves sometimes nitrogen. So what is the balanced equation for that? Or the question may be like this: CXHYNZ plus, if I again burning with it the this one with O2, X plus Y by 4 O2 gives you XCO2 plus Y by 2 H2O plus Z by 2 N2, right? This is the N2 molecule. See this is same. The difference lies here. This one N2 and nitrogen molecule is like this, Z by 2 N2. The difference lies here. Just a minute. Now the third concept, now the in the sometimes in the question they may ask, and this is the trick. The contraction in the volume is given. I told you earlier as well in this video only. Now how to calculate the contraction in the volume? Volume contraction means there the volume contract, some contraction is there in the volume. So the volume contraction is equals to volume of reactants minus volume of product. This is the way to calculate the contraction in the volume. This is the volume of the reactants. Reactants are there. This one are the reactants, right? This is also reactant, and this one is product. So volume of product is this, and volume of reactant is this, right? Now I will discuss some basic questions, and the interesting question as well. You can do whatever the type of level question you can solve. You can solve that. Let me use another page. The first question says 8.4 ml of a gaseous hydrocarbon A was burned with 50 ml of O2 in an idiometry tube. The volume of the products after cooling to room temperature was 37.4 ml. The volume of product is given. This one is the volume of product. When reacted with NaOH, the volume contract. See the contracted by I have told you in earlier concept. The contracted volume is used here. To 3.8 ml. What is the formula of the hydrocarbon? They are asking. So this one is a easy question, but most important for the basic when you are starting with the iodometry. So um, here's the solution. Question number 1. I've told you the equation of the hydrocarbon burning with the O2. What is the balanced equation? You remember? CXHY plus X plus Y by 4 O2 gives you XCO2 plus Y by 2 H2O. So you remember this. And from the Gay-Lussac law of combining volumes, we have one volume. This is the basic concept I'm telling in this question. It's a very important question for the basic. One volume of CXH4 is equals to X plus Y by 4 volume of O2 is equals to X volume of, this is the volume of CO2 is equivalent to Y by 2 volume of H2O. Now in the question, now volume in the question it says 8.4 ml of gaseous hydrocarbon, 8.4 ml, right? And about this, what is given? 50 ml of O2 is given. See, 50 ml of O2, right? 50 ml O2, that means it's 50 ml. And the product itself is 37.4 ml, right? It is given in the question. Now what we have to do, um, we have to solve this question. Now we have to calculate the volume contraction. Contraction, first of all, so that we can find x and y. Basically they are asking for the hydrocarbons, so we need to find x and y. So volume contraction in volume is equals to volume of reactant minus volume of product, which is equals to 8.4, this one, plus 50 reactant minus 37.4 it is given. On calculating this we get this one goes 37 minus that we then we get 21 ml, yeah, right. Now this is the 21 ml we have included. Now we have to calculate this from equation as well, so that we can find the value of y or x, whatever be the situation according to the question. So calculate contraction in volume from the above equation. How to find this volume of, I've told you this one, right? So what we do, contraction is equals to 1 plus this one volume of CxH4, x plus y by 4, this is the water, minus x. Now this is of CO2 plus 0, this one is of product, this one is of reactants. So why 0? Because H2O, this is of H2O volume, and volume of H2O is not taken as it is in condensed form में, right? So it is 0. Volume of H2 is not taken in the equation, right? This is the result you can remember for solving question, right? Now these both are what, equal. So I will put 21 equals 1 plus x plus y by 4 minus x, right, equals 24. Now x goes with this, so on calculating we get y equals 6. Now we have calculated y, this is the y, I can put it here, y, I know the value of y, but we need to find the value of x as well. How to get that? It is written in the question, when treated with NaOH, the volume contracted to 3.8 ml. Now this part will give us the value of x. So after treating the volume contracted to 3.8, so we I forgot to mention that only the NaOH, the NaOH react with only with CO2. CO2, it react with only CO2, not with H2O, because NaOH is basic and CO2 is acidic, so it will react. Sorry, I forgot this one is for, I have to multiply with this 8.4, then I will get 6, right? Yeah, I just remember the value of y, so I put it here, sorry for that. But we have to multiply with 8.4. Why? Because it is written in the question 8.4, when we are, this is given one volume, but in the question it is given 8.4 ml of this is reacting with this 50 ml of this, and we are getting the product. So we have to multiply with 8.4. Now After treating with NaOH, the volume protected to this. Now, what we do, volume protected to, so 37.4, this is the volume of the product, minus volume of CO2 is equals to 33.6, right, ml. Volume of CO2 we can calculate. It comes out to be, sorry, 3.8 is given, right? 3.8. So volume should come to be 33.6, yeah, 6, yeah, 6 ml, right? Now this is 33.6 ml, 33.6 ml. Now it is given, so 8.4, this is for one volume, this is for one volume, this is for one volume of CX4, but we have to multiply with 8.4, volume of, this is x volume of given x, so we would multiply with 8.4 x, which is equals to 33.6 is the volume of CO2 we have calculated from here, right? So on solving this, x equals, I think I solve this, it's 4, yeah. So the formula is CXHY is equals to C4H6. I have taken a time, sorry for that, but this is a basic question and important question for the beginners, and this important tricks are involved in this question, important tricks, so I have done this. So, okay, second question. Now this is the second question. What does it says? 15 ml of gaseous hydrocarbon required for complete combustion, 357 ml of air, 25% of O2 by volume. Okay, and the gaseous product occupied 327 ml, right? And all volume was measured STP. What is the formula of hydrocarbon? Now we know that air in it is a mixture of O2 and nitrogen as well. These are major components, right? Now let's start. So solution, solution 2. Let the hydrocarbon be CXHY. Now I told you the equation, CXH